Assalamu alaikum everyone. Welcome to Maths Magic Hub. In this video, we will look at some examples on scalar product and its applications. Example 1. P is equal to 8i minus 6j minus 10k and q vector equals to 4i minus 3j. Show that the angle theta between the two vectors is 45 degree. Well, we are given two vectors p and q, and we have to show that the angle between the two vectors is 45 degree. By definition of the scalar product, we know that the scalar product between two vectors p and q is p dot q is equal to p mod q mod cos of theta. This implies cos of theta is equal to p dot q divided by p magnitude into q magnitude. So in order to find theta between the vectors, first we find dot product between the vectors. Now by previous video, we know that p dot q is equal to 8 multiplied by 4. Just multiply the like components in the two vectors and add them. The j component of the two vectors is minus 6 and minus 3. The k component in the first vector is minus 10, whereas there is no k component in the second vector, means it's 0. Simplify these expressions to get the value of p dot q, which is equals to 50. Now, the magnitude of the vector p is p mod equals to square root x component square, that is 8, plus y component square, that is minus 6, plus minus 10 square. Simplifying these expressions, we get 64 plus 36 plus 100, which is equals to square root of 200. Similarly, the magnitude of the vector q can be calculated as q mod equals to square root of x component square plus y component square, and there is no z component in the vector q. This is equals to 16 plus 9 square root, that is equals to 5. Using the values in equation 1 becomes cos of theta is equal to p dot q is 50 divided by value of p mod is 10 square root 2 and that of q mod is 5. We can write it as 50 divided by 50 square root 2. Cancelling 50 with 50, we get 1 over square root 2. So theta is equal to cos inverse of 1 over square root 2, and by using calculator we get theta is equal to 45 degree, which is the required angle between the vectors p and q. Example 2. In this example, we are given the position vectors of 2 points A and B, OA and OB, and we have to find the angle OBA. Now always draw a sketch to choose the right directions for the two vectors to find the angle OBA. Let us call this angle be the angle theta. We are given the vector OB and the vector OA, and we have to find the angle theta. Clearly, angle theta is the angle between the vectors OB and AB. So first we will find the vector AB. The vector AB can be calculated as AB vector is equal to OB vector minus OA vector. Using the values of OB and OA, OB is minus 1, 3, minus 1, minus the vector OA is 5, minus 2 and 4. Subtracting the like components, we get minus 6, 5 and minus 5. This is the vector AB. Now, using the dot product between the vector AB and OB, we can write cos of angle theta is equal to OB dot AB divided by magnitude of the vector OB into magnitude of the vector AB. Let us call it equation number 1. Now OB dot AB is equal to dot product of OB is minus 1, 3, minus 1, with the vector AB is minus 6, 5 and minus 5. Now by using the formula, the dot product can be computed by multiplying the like components and then combining. Minus 1 into minus 6 plus 3 into 5 plus minus 1 into minus 5. This is equals to 6 plus 15 plus 5, which is equals to 26. So OB dot AB is equal to 26. Now the magnitude of the vector OB is equal to square root of minus 1 square plus 3 square plus minus 1 square, which is equal to square root of 1 plus 9 plus 1, that is equals to square root of 11. Similarly, the magnitude of the vector AB is equal to square root of the components minus 6 square plus 5 square plus minus 5 square, which is equals to square root of 36 plus 25 plus 25, which is equals to square root of 86. Now using the values in equation 1, we get cos of theta is equal to OB dot AB is 26 divided by magnitude of OB is square root 11 into magnitude of AB is square root of 86. So theta is equal to cos inverse 26 divided by square root 11 into square root 86. Using calculator, we get theta is equal to 32.3 degree to 1 decimal place. So this is the angle between the given two vectors, that is the angle OBA.